In 1970, deep in the frozen landscape of northern Russia, Soviet engineers began a project unlike any other in human history. They set out to drill the deepest hole on Earth. This wasn't just a quest for a world record. It was a scientific mission driven by Cold War ambition. Just as the space race aimed for the stars, the race to the Earth's center was about proving technological and ideological superiority. The goal was the Kola Superdeep Borehole, a testament to human ingenuity aimed at piercing the very crust of our planet. The plan was ambitious, targeting a depth of 15,000 meters, far deeper than anyone had ever gone before. Soviet geologists were confident. They had sophisticated models of the Earth's crust, built upon decades of seismic data and geological theory. They believed they knew exactly what they would find. The first few years of drilling seemed to prove them right. The drill bit, a marvel of engineering, chewed through granite rock. Just as predicted, temperature and density measurements aligned perfectly with their charts. Everything was going according to plan. The scientists and engineers felt a sense of reassurance. They weren't just drilling, they were confirming the foundational principles of their field. The Earth, it seemed, was as predictable as their textbooks said it was. But our planet is full of surprises. That comforting predictability began to shatter at a depth of 7,000 meters, about 4.5 miles down. According to all seismic data, this was the point of the Conrad discontinuity. It was a well-established boundary where the granite layer of the upper crust was supposed to give way to a much denser layer of basalt rock below. The engineers held their breath, waiting for the drill to report a change, but the change never came. The drill continued to pass through the exact same type of granite it had been grinding through for kilometers. There was no basalt, no boundary, just more granite. This wasn't a minor discrepancy. It was a geological bombshell. The Conrad discontinuity was a cornerstone of crustal models worldwide. Its absence in one of the most direct geological surveys ever conducted was deeply troubling. It suggested that the way scientists interpreted seismic waves, the very method they used to map the Earth's interior, might be fundamentally flawed. Imagine discovering that the maps you've used your whole life are based on a wrong assumption. That's the scale of the problem they faced. The project leaders were faced with a dilemma. Should they announce this revolutionary finding? If their data was somehow mistaken, it could be a huge embarrassment. But if the established models were wrong, the implications would shake the entire field of geology. They chose to proceed with caution, drilling deeper, hoping for an explanation. But as they went further, the Earth only became stranger. One of the next major shocks came in the form of water, at depths of several kilometers, where the immense pressure and heat were thought to make liquid water impossible. Core samples revealed its undeniable presence. Microscopic cracks within the rock held ancient water, trapped for millions, perhaps billions of years. The rock that was supposed to be a solid, impermeable barrier was actually behaving more like a sponge, allowing water to slowly seep down over geological timescales. This discovery forced scientists to rethink the very nature of rock under extreme pressure and the potential for deep, hidden reservoirs of water within the Earth's crust. And then there was the heat. The temperature models had predicted a steady, manageable increase as the drill descended. By the time they reached their target depth, they expected temperatures around 100 degrees Celsius or 212 degrees Fahrenheit. But reality was far hotter. At just 10 kilometers down, the temperature was already soaring past 180 degrees Celsius or 356 degrees Fahrenheit. This was nearly double their prediction. The extreme heat was a game changer, and not in a good way. At these temperatures, the rock itself began to change. It wasn't brittle anymore. It became soft and almost plastic, flowing around the drill bit instead of breaking. The drill, designed for solid rock, struggled against this hot, deformable mass. Equipment began to fail catastrophically. Drill strings, the long pipes connecting the surface to the drill bit, would twist and snap under the immense stress. Entire sections of the borehole, representing years of work, would collapse and have to be abandoned. The team had to repeatedly pull back and start drilling new branches off the main shaft, but each attempt ran into the same fiery wall. The Earth was actively fighting back, its intense internal heat proving to be a far greater obstacle than anyone had ever imagined. But perhaps the most profound discovery was yet to come. It was something that defied the known limits of biology and chemistry. From a depth of over 6 kilometers, in a core sample of granite that was over 2 billion years old, researchers found fossils, not bones or shells, but microscopic fossils, the perfectly preserved remains of 24 different species of single-celled marine organisms. Plankton. Finding these tiny organic traces was a miracle. According to all scientific understanding, the extreme temperatures and pressures at that depth should have obliterated any organic material long ago. Yet here was definitive proof that life, or at least its chemical signature, could be preserved under conditions previously thought to be completely inhospitable. It was a discovery that blurred the line between geology and biology, suggesting that the history of life on Earth could be written not just in sedimentary rock on the surface, but deep within the planet's crystalline foundations. The anomalies kept piling up. As the drill churned deeper, the drilling mud that was pumped down to lubricate the bit and carry rock fragments back up started to return to the surface, bubbling. It was saturated with huge quantities of hydrogen gas. Where was it all coming from? Was it ancient gas that had been trapped in the rock for eons? Or was it being actively produced by some unknown chemical reaction between the superheated water and the rock deep below? Scientists didn't have a clear answer. This boiling mud was yet another puzzle. Another piece of evidence that the deep Earth was a far more dynamic and chemically active place than the static models had ever allowed for. The missing basalt, the trapped water, the soaring temperatures, the ancient fossils, and the mysterious hydrogen gas all pointed to a single, powerful conclusion. The Earth's crust was not a simple, layered cake of predictable rock types. It was a complex, porous, and geochemically active system, full of processes and secrets that science was only just beginning to comprehend. By the early 1990s, the project's biggest challenges were no longer just geological. With the collapse of the Soviet Union, the political will and, crucially, the funding for this monumental scientific endeavor evaporated. The extreme heat and technical failures had already slowed progress to a crawl. In 1992, drilling officially stopped. The deepest point reached was 12,262 meters, or just over 7.5 miles. They fell short of their 15-kilometer goal. But they had still secured the world record for the deepest artificial point on Earth, a record that stands to this day. The site was eventually abandoned, and the borehole was sealed, capped with a heavy, bolted metal lid. Today, it's just a rusty ruin in the Arctic wilderness, a forgotten monument to a bygone era of scientific ambition. So, was the project a failure? It never reached its target depth, and it was ultimately abandoned. But to call it a failure is to miss the point entirely. Years later, as researchers from around the world analyzed the complete data set from the Kola borehole, its true legacy became clear. When the findings were first shared, many in the geological community were skeptical. The results were so radical that they seemed impossible. But as other deep drilling projects in countries like Germany and Sweden began to encounter similar surprises and expected heat, water, and gases, the evidence from Kola could no longer be ignored. The Kola Superdeep Borehole had succeeded in the most important way a scientific experiment can. It hadn't confirmed what we thought we knew. It had revealed the limits of our knowledge. It forced a generation of scientists to question their most fundamental assumptions and rewrite their textbooks. It proved that, no matter how sophisticated our remote sensing and theoretical models are, there is no substitute for direct observation. The real value wasn't in reaching a specific number on a depth gauge. It was in the core samples brought to the surface, each one a message from a world we thought we understood. The Kola Superdeep Borehole is not a story of failure, but a story of humility. It's a powerful reminder that the ground beneath our feet is not a solved problem. It's a dynamic, mysterious, and still largely unexplored frontier, holding secrets that no model can fully predict. The Earth still has so much to teach us, if we're brave enough to listen. Thanks for watching. If you found this journey into the Earth as fascinating as I did, make sure to hit that like button and subscribe for more deep dives into the mysteries of our world. See you next time.